Hello all, welcome to the introduction video of Kubernetes. My name is Karthik Reddy. In this video I am going to explain what Kubernetes is, why Kubernetes, and what it does, and its feature and finally architectural overview of Kubernetes. This video makes you comfortable in terms of understanding basics of Kubernetes. What is Kubernetes? Let's look at the definition. Kubernetes is an open source system for automating deployment, scaling, and management of containerized applications. I understood. Very tough to understand, right? Don't worry. Now let's try to explain it in simple language. We know that most of the applications these days are built on containers. Let's imagine having hundreds of containers to run one or more applications and services, but not having a way to manage or orchestrate them. So that's going to create a lot of problems and mess, isn't it? That's where Kubernetes comes into picture. Kubernetes is management software for containers. You write a specification and it manages the creation, configuration, and deletion of containers and other things, besides reacting to changing conditions. Why Kubernetes? I will explain a real-time scenario to understand why Kubernetes is used widely. Many companies, a lot of organizations may be using Docker or maybe simply Linux containers for containerizing their applications. Remember, I'm talking about a company here which is very huge and which may have a lot of applications. So they don't stop at using one or two containers in production environment, but they use hundreds or thousands of containers for load balancing the traffic and ensuring high availability. Here the problem comes. So the workload increases, traffic increases, and what happens? They have to increase the number of containers, that is scaling up containers to serve huge number of requests that comes in every second, and they have to also scale down the containers when the demand is less. So do you think can all this be done natively? No, it's not, or not even manually. That is why the need for container management tools is important. So what are those tools? So there are two types of tools what I know. So they are Docker Swarm and Kubernetes, which are popular tools for container management and orchestration. So this explains us why we need to use Kubernetes. So because containers are a good way to bundle and run your applications. So in a production environment, you need to manage the containers that run the applications and ensure that there is no downtime. For example, if a container goes down, another container needs to start. So that's how Kubernetes comes into risk. So Kubernetes provides you with a framework to run distributed systems resiliently. It takes care of scaling and failover for your application, provides deployment patterns. Next, what does Kubernetes do? So before moving to this thing, I hope it's very clear why to use Kubernetes. So if you think of using containers massively for your applications and services, then you have to think about managing your containers. If so, then think about using Kubernetes. Okay. So now let's see or let's understand what Kubernetes will do for us. It improves the reliability. It continuously monitors and manages your containers, which is good. It will scale your application to handle changes in load. Better use of infrastructure resources. It uses your infrastructure resources in a better way. It helps reducing infrastructure requirements by gracefully scaling up and down your entire platform. It coordinates what containers run where and when across your system. How do all different types of containers in a system talk to each other? It easily coordinates deployments of your system, like which containers need to be deployed, where should the containers be deployed. So now all together, Kubernetes is all about managing lifecycle for containers. That is, container orchestration, container infrastructure, and operations management. Well, so now let's understand features or benefits of using Kubernetes. following are features. So there are different types of features that Kubernetes provides. So they are service discovery and load balancing, storage orchestration, automated rollouts and rollbacks, automatic bin packing, self-healing, secret and configuration management. So what are they? Let's look at them one by one. Service discovery and load balancing. With Kubernetes, there is no need to worry about networking and communication because Kubernetes will automatically assign IP addresses to containers and a single DNS name for a set of containers. So that can load balance traffic inside the cluster. And what is storage orchestration? With Kubernetes, you can mount the storage system of your choice. You can choose for local storage or you can choose a public cloud provider such as Google Cloud or Amazon Web Services or Microsoft Azure. Or perhaps you can use a shared network storage system such as NFS. Next is automated rollouts and rollbacks. What is this? Kubernetes progressively rolls out changes and updates to your application or its configuration by ensuring that not all instances are worked at the same instance. Even if something goes wrong, Kubernetes will roll back the change for you. And next is automatic bin packing. What is this? Kubernetes automatically packages your application and schedules the containers based on their requirements and available resources while not sacrificing availability, which is excellent. To ensure complete utilization and save unused resources, Kubernetes balance between critical and best effort workloads. So this is it's intelligent thinking of Kubernetes. And next is self-heal. So personally, I love this feature because Kubernetes can automatically restart containers that fail during execution and kills those containers that don't respond to user-defined health checks. But if node itself dies, then it replaces and reschedules those failed containers on other available nodes, which is a fantastic feature. Next one is secret and configuration management. So this feature is related to security. Kubernetes can help you deploy and update secrets and application configuration without rebuilding your image and without exposing secrets in your stack configuration. I hope now it's clear on what Kubernetes is and how it helps to manage containers. So now let's understand the components and architecture of Kubernetes. Kubernetes components. When you deploy Kubernetes, you get a cluster. And what is cluster? A cluster is a set of missions called nodes that run containerized applications managed by Kubernetes. A cluster has at least one worker node and at least one master node. So what is a worker node and what is a master node? The worker node hosts the parts that are components of the application. The master node manages the worker node. The master node, it manages the worker nodes. Master node is otherwise it is called as control plane of your cluster, or else it's called as it is the brain of your Kubernetes deployment. So which is very important. So the master node manages the worker nodes and the pods in the cluster. Multiple master nodes are also used to provide a cluster with failover and high availability. So please remember this. So it's not limited to only one master node. You can use multiple master nodes to achieve high availability and failover at cluster level. So now let's look at master node components. So we have like 4 components in a master node. So they are Kube API server, etcd, Kube scheduler, Kube controlled manager. So what is the purpose of these components? So now we will have a look one by one. First one is Kube API server. What is it? The API server is the central management entity and the only component that directly talks with the distributed storage component. So this is very important. So this is the only component The API server is the only component which talks with the distributed storage component, nothing but etcd. So in a master node, we have four components, but API server is the only component which talks to the storage system, storage service, etcd. So API server provides the following. API server provides a lot of core functionalities. So some of them are, it serves the Kubernetes API. API server, it serves the Kubernetes API. So which is used in cluster internally by the worker nodes and as well as externally by kubectl. It proxies cluster components such as the Kubernetes user interface. It allows the manipulation of the state of objects, for example, pods and services. It persists the state of objects in a distributed storage, that is etcd. So this is about Kube API server. So what is etcd? As I told, in Kube API server, etcd is a distributed key value store. It is strongly consistent, that provides a reliable way to store data that needs to be accessed by a distributed system or cluster of machines, nothing but your Kubernetes cluster. So simply, this is used to store the state of Kubernetes cluster configuration or its data. That is etcd. So what is next component? Kube scheduler. What is this? What is the scheduler for? The Kubernetes scheduler is in charge of scheduling pods onto nodes. Basically, it works like, for example, you are creating a pod. The scheduler notices that the new pod you created does not have a node assigned to it. So the scheduler assigns a node to the pod. So that is the job of scheduler, a basic job of scheduler. But you have to remember one thing here. It's not responsible for actually running the pod. Scheduler is not responsible for running the pod. That's the job of kubelet, which we will see in while we are discussing about worker node components. So it just needs to make sure every pod has a node assigned to it. So I hope you understand. It's easy. Yeah, that's right. So next component is kube control manager. What is this? In Kubernetes, a controller is a control loop that watches the shared state of the cluster through the API server. So your kube controlled manager will be listening to the API server, and it is like, it will be keep on watching the state of your cluster, and it attempts to move the current state to the desired state. So example of controllers that ship with Kubernetes today are replication controller, endpoints controller, namespace controller, and service accounts controller. So for example, controller manager is responsible for monitoring replication controllers and creating corresponding parts to achieve the desired state. So it's all about, achieving the main philosophy of Kubernetes cluster. So achieving the desired state from current state. It's like that. So now let's go to worker node components and quickly look what are the components in worker node. So in worker node components, we have three components: kubelet, kubeproxy, and container runtime. What is kubelet? The kubelet is responsible for maintaining a set of pods which are composed of one or more containers on a local system, on a node. So what is this? So kubelet is nothing but, it is responsible for, monitoring, watching the health of your pods. Within a Kubernetes cluster, the kubelet functions as a local agent that watches for pod specs via the Kubernetes API server. So this is very important, as I told. So it will be watching, or it will be monitoring the pod health via Kubernetes API server. So the kubelet is also responsible for registering a node with a Kubernetes cluster and sending events, sending pod status, and reporting resource utilization. It's clear. I hope it's clear now. So kubelet is, all is, it's like, responsible for maintaining a set of pods, and it is responsible for sending events, pod status, resource utilization on node to your master or to API server. So that is about kubelet. Now, kube proxy, what is this? Kube proxy is nothing but a network proxy that implements the service abstraction. It uses or it programs the IP table rules on the node to redirect service IP requests to one of its registered backend pods. Kubeproxy can also work as a load balancer for the service pods. It can do simple TCP UDP stream forwarding or round robin TCP UDP forwarding across a set of backends. That's about kubeproxy. And the last component in worker nodes is container runtime. It's very simple. It is like Docker. So Docker, what is Docker? It's a runtime engine. So to execute containers on the node, that's it. So every node will have a container runtime. Kubernetes, if you see Kubernetes, most of the time it uses Docker as a default thing, or we have some other containers you can use like CRI, and there are many. Yeah. So let's jump into Kubernetes objects. Kubernetes objects are entities that are used to represent the state of the cluster. As I told, the philosophy of Kubernetes, it is, to achieve the desired state. Kubernetes is always working to make an object's current state equal to object's desired state. So Kubernetes objects details are pod, daemon set, deployment, replica set, job, and many more. So if you want to know what these objects are, yes, definitely we can simply have a look what each object and what is the functionality of each object. So if you take pod, a pod is a collection of containers that share some resources. So they have a single IP and they can share volumes. What is a daemon set? A daemon set ensures that all or some nodes run a copy of a pod. To understand more about daemon sets are useful for deploying ongoing background tasks that you need to run on all or certain nodes, and which did not require user intervention. Examples of such activities include log collection daemons like fluentd. If you want to collect logs for all of your components running in a node, then you can use this log collection daemon, which is called as fluentd. And if you want to monitor node statistics, then you can use monitoring daemons like collectd. That's it about daemon set. What is deployment? Deployment is a way to define the desired state of pods or a replica set. Deployments are used to define high availability policies to your containers by defining policies around how many of each containers must be running at any given point of time. Replica set. A Kubernetes replica set ensures that a specified number of pods in a replica set are running at all times. If one pod dies or terminates or crashes, the replica set configuration will ensure a new one is created in its place. What is job? Job is nothing but it ensures a pod properly runs to completion. As simple as that, right? Service. So don't worry about single line definitions, but once you start practicing the concepts, or once you start deep diving the Kubernetes tutorials or real-time scenarios, then you will understand exactly what each and every object means, how they works, and what is the configuration we have to do to achieve the object desired state, everything. So now let's go to service. What is a service? Service maps a fixed IP address to a logical group of node pods, and service helps for coupling of a set of pods to a policy by which to access them. Services are used to expose containerized applications to origins from outside the cluster. So label. What is a label? Label is a simple key value pairs used for association and filtering. So you can learn much more about labels when you are working or when you are writing a YAML file or spec file for any object. Namespaces. Namespaces are a way to create multiple virtual Kubernetes clusters within a single cluster. Namespaces are normally used for wide-scale deployments where there are many users, a lot of teams and projects. Well, so next is architecture. So you can see the architectural view of Kubernetes cluster. So if you see this path, this is control plane. So this is nothing but master node in a Kubernetes cluster. It's a brain of Kubernetes cluster which has several components that we have already seen in the earlier slide. We can see a scheduler here, a controller manager and an API server. So API server is the only server which is communicating to etcd. And here you can see this is the data plane. So data plane is nothing but a worker node. So the components of worker node you can see here is you have kube proxy, you have kubelet, and which are communicating with pods, containers in the node. And you can observe the communication paths between the master and the Kubernetes cluster. So Kubernetes cluster is nothing but a worker node in this architecture. So communication path from worker node to master terminate at the API server. What is that? That is, none of other master components are designed to expose remote services. So there are two primary communication paths from master to the worker. The first is from the API server to the kubelet process, which runs on each node in the cluster. For example, this type of communication is used for fetching logs from pods. And the second one is, it is from the API server to any node, pod or service through the API server's proxy functionality. I hope you understood. So now, finally, how to set up the cluster. So there are many tools available to help bootstrap and configure a self-managed Kubernetes cluster. So few of them are Minikube, Kops, KubeADM. So what is Minikube? Minikube is a tool that makes it easy to run Kubernetes locally. Minikube runs a single node Kubernetes cluster inside a virtual machine on your laptop for users looking to try out Kubernetes. So basically it's a learning environment. I would recommend to do a lab using Minikube to understand the concepts practically. And Kops. Kops is an official Kubernetes project for managing production Kubernetes clusters. Kops is currently the best tool to deploy Kubernetes to Amazon Web Services. So if you want to set up Kubernetes cluster in AWS, then use Kops. It will do everything for you in AWS. All you need is an AWS account. Very simple. Next is KubeADM. KubeADM is a tool developed by Kubernetes which allows you to create a minimum viable cluster up and running. So it is like it will give you a standalone cluster which is up and running. Please remember, it will only bootstrap your cluster, but it will not provision any missions for you. Okay. And there are many more like Crib, KubeSpray, EKS from AWS, AKS from Microsoft Azure, etc. Well, time to say thank you guys. Thanks for investing your time to learn basics of Kubernetes. See you in next lecture. Bye bye.